It's Wendell again, and here we're still on factorizing polynomials. Now we're looking at the third method that we want to use to factorize. Here it is, factorizing by the AC method. The AC method is one that is used specifically to factorize things of a quadratic format. Remember, in a quadratic, the general form is ax squared plus bx plus c. Now, from time to time, the b and the c might not be there, but what really makes it a quadratic is the fact that the highest power of the variable is a 2. So this is a quadratic system. Most times it is written in the form where we have descending powers of the variable. For example, we see an x to the second, then an x to the 1, and then an x to the 0, and that is why we don't see it. X to the power of 0 is 1. We don't see it, so we have a constant. Now, what does this do for what we're about to do? We have to be able to isolate A, B, and C. These are numbers. These are numbers, and the A, as you can see, is the coefficient of the x squared, which means it's a number in front of the square of x. The B is the number in front of the x, and the C is the constant without any variable attached to it. It is called the AC method because we're going to be using A to multiply by C as a means of helping us to get along with our final thing. So let's see a problem. Let's look at some cases. Let us say we have 3x squared minus 7x minus 6. This is a quadratic. Now, if we could quickly run through to see if any of these could work, we'd realize that the highest common factor cannot work because there is nothing common for all three. We'd realize that grouping cannot work either because grouping will need 4 terms, at least 4 terms. We only have 3. AC method, I'm seeing where we have an A, which is 3, and I'm seeing a C, which is negative 6. So I'm going to write out my A, B, and C. A, which is 3, which is the coefficient of the x. B, negative 7, which is the coefficient of the x. A is the coefficient of the x squared. B is the coefficient of the x. And C is just a constant, negative 6, without any variable attached to it. It is called the AC method because we need to find AC. So let us quickly look at AC. AC means A times C. This is 3 times negative 6. So 3 times negative 6 will leave us the negative 18. Another way in which people term this is they call it a product sum method. Because whenever you find the AC, that value, we need to find a product that will give AC. For example, factor pairs, 2 things that multiply to give back our negative 18. And if we should add those same 2 things, we will get back the B value. So that is why some people call it the product sum, because we multiply those things to get back AC. Also, we add to get back our negative 7. So the best thing to do is to list all the factors of AC. 1 times 18 could give us 18. 2 times 9 could give us 18. 3 times 6 could give us 18. The good thing about the AC method is that the factor pairs are limited because we only have 1, 2, 3 pairs that really could multiply to give us back 18. Now remember, this is a negative 18. So the truth is, all of these numbers, they are positive and they are also negative. What we need to do now is to zoom in. Think about this. If 2 things should multiply to give a negative number, 2 things should multiply to give a negative number. Based on what we learned in directed numbers, 1 of them will be positive and 1 will be negative. We are certain 1 will be positive and 1 will be negative. So let us pick those factor pairs first that could give us a 7. So normally I would say to people, if you could add or subtract these and you're getting back your B, select that and then we work on it. For example, if we should add this to this, we can get a 19. If we should take away, we'll get 17. I don't have 17. If we should add these, I could get a 9. If I should subtract them, I could get a 3. I don't see a 3 for B. But when we look at the 2 and the 9, if you should add, you could get 11. But if you subtract, you could get 7. And there goes what we want. We can get a 7 from this. So here is the thing. We're going to isolate these two factor pairs. Now, one must be positive and one must be negative, such that when you multiply, you'll get back a negative response. Well, the rule is if one must be positive and one must be negative, we are going to let the bigger one take any sign B has. The bigger one must take any sign B has, and B is negative 7. So at this time, it's a negative 9. So let us quickly check back. 2 times negative 9, negative 18. 2 plus negative 9, negative 7. So these two numbers, which are factor pairs of 18, are what we need to be our replacement for our negative 7x, which means we will be writing back our 3x squared. We'll be writing back our negative 6. These will replace the negative 7. Therefore, they will take on the variable x. So you could write any one of them first. Plus it positive 2x minus 9x. So basically, what we have here is a substitution for negative 7 written in a unique way by finding the factor pairs. Now, if you look on what we have now, we have 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. Now 4 terms and we don't have anything in common. We are back at stage 2. Now we are going to employ grouping. So let's look. Do we have anything in common here? Yes, we do. We have x in common. Do we have anything in common here? Yes, we do. We have a 3, or you could say a negative 3. So now we have our first pair and our second pair, pair 1, pair 2, and we do find things in common. Now, this is the beauty about math. I'm doing the AC method. Now I'm at grouping, but for me to group something, I am all the way back to highest common factor. So let us look. What's the highest common factor for this pair? The highest common factor is x. X into 3x squared cancels that, leaving 3x. X into positive 2x, we're left with 2. What's our highest common factor here? I have to be very careful now because I need to create an identical bracket to this. So I will use negative 3 because negative into negative would give me positive. So negative 3 into negative 9 will give me positive 3, and we have an x. Negative 3 into negative 6, we have a positive 2. Now this bracket is exactly like this bracket. Now we're going to factorize again because we cannot leave it when there is a common factor. The common factor is 3x plus 2. Now if I should divide 3x plus 2 into this, the 3x plus 2 cancels itself, leaving x. If I should cancel the 3x plus 2 into this, it's going to leave me with negative 3. And here is our factor. 3x plus 2 into x minus 3. Thank you for watching.